So the city of Charlottesville and Albemarle County, it's a relatively small metro area, population less than 150,000, but growing relatively rapidly. It is the home of the University of Virginia. Also a picture here showing the downtown walking mall in Charlottesville. And then there are a number of historic sites. Tourism is common in the area, including Monticello, the home of Thomas Jefferson. And as far as my organization, we are the MPO, as well as planning for some of the surrounding counties. And we're a relatively small staff with 2 planners dedicated to transportation. So for the Jefferson area bicycle and pedestrian plan, like I said, we just wrapped this plan up, worked on it for over a year. And the vision of this was to bring together multiple planning efforts and provide a guide for implementation on a regional scale. So the city and county both had separately a number of plans for bicycle and pedestrian infrastructure. And so the goal of this plan was to bring them together and to show what a regional network could look like and what that would include. And, and there are some rural recommendations, but a lot of the focus was on the urban areas. And so in the plan, we identified regional corridors and then prioritized those corridors. So the corridors were identified with significant public input, and there what's shown, if you can kind of see the lines on the map there on the right. And we identified a few different types of infrastructure too, shared use paths, and then on-road facilities, so bike lanes with sidewalks or even shared roadways with sidewalks is what's shown on that map as far as the regional corridors. And then these corridors were split into segments or projects essentially, and these were assessed with the Active Trans Priority tool to identify the relative benefits. So we ended with tier 1 segments or tier 1 projects, tier 2 projects, and tier 3 projects. So a relative prioritization of where the region could be putting their resources to best build the regional bicycle and pedestrian network. So it's this prioritization that I'll be talking about specifically. As I mentioned, we use the Active Trans Priority tool, which is a flexible methodology, and we used it quite flexibly. There are many possible categories and variables that can be used for evaluating projects, and we used 5 listed here. So projects were scored higher if they were close to destinations, so schools, libraries, parks, and also population and employment centers. Also, projects scored higher if they were had more equity benefits. So we're close to residents in poverty, residents who are a minority, or households with 0 vehicles. Projects also scored higher if they had more improvement over existing conditions. So if there was already a bike lane and a path was being proposed for the same corridor, that was great, but it wasn't scored as highly if there was already something there. And then connectivity was also used, so crossing a river or stream or a political barrier even was something that also scored projects, led projects to have a higher score. And then demand, so looking at estimating the relative number of people who would use each segment, each corridor. And so this is where we use StreetLight Data tools. And finally, we did, after this prioritization was done, adjust it in a few ways, but the core of our prioritization for the region was done with this Active Trans Priority tool. So on the estimating demand side, when we were looking at other examples of people who've used the Active Trans Priority tool to evaluate bicycle and pedestrian projects, the most common method of estimating demand appeared to be vehicle AADT. So looking at a road or a road adjacent to a bicycle and pedestrian facility, looking at the AADT on that road and saying that that's an estimate of the number of people who would bike or walk on a pedestrian or bicycle facility. And we saw a couple, challenges with that. It would lead to prioritization of projects along high volume roads, which is exactly the place you might not want to walk or bike. And also it doesn't take into account whether these trips would be feasible by walking or biking. So the trip length in particular, a highway might have a very high AADT or even a major arterial, but a number of those trips might be going through the region or might be going a very long distance. So instead of using AADT in any way, we decided to use a StreetLight Data analysis to get information on the relative number of trips that are less than 5 miles for each of these corridor segments that we were identifying. So less than 5 miles was seen as a more appropriate estimate of the potential bicycle and walking trips for the projects we were identifying. And something I'll get into on the next slide is that the StreetLight tools also allowed greater flexibility for estimating trips that might use new connections. So where there's not a current road, but where there's a bicycle or pedestrian path or facility indicated that, you can't look at AADT and say how many people might use it. We're able to use StreetLight to come up with an estimate of the relative number of trips that might use that new connection. And one note, we are using relative number of trips less than 5 miles. I'm not aware of any data-driven reason that 5 miles would be a cutoff, but that was, for one thing, one of the numbers StreetLight gave, and then also just seemed logical to us as far as there won't be that many people walking or biking for transportation, particularly more than 5 miles. So a bit on the methodology here. We used the LBS with paths through data from January to April 2018. We did look at all day, all times of day and all days of the week. So that's what was used on all the different links that we evaluated. And we drew pass-through zones for each project being evaluated. So where there was a bicycle or pedestrian corridor along a road, we ran OD to preset geography for the trips that were occurring. So again, this is the all modes trips that were occurring on those roads. And then what I referenced before was that we did have a number of instances where we were suggesting a new connection for bicycles and pedestrians that is not close to an existing road. And in that case, the few times we had this, it was basically where there was one main road into the central area of Charlottesville, kind of the downtown or the larger core, urban core. And so there would be a bicycle facility along that road, but there would be a separate one that would lead to a different part of the urban core. So the cases where we did this, we're able to kind of draw destination geographies and identify the people who were traveling on the main road, whether they were going, say, to the east part of the downtown or of the urban core or the west part of the urban core. And based on the destination of the people along these roads, we're able to split up and say, okay, this relative number of people will be traveling to the east part of the urban core, so they'll use the new bicycle and pedestrian connection that's proposed versus the number of people who are traveling to the west part of the urban core who would use probably a facility along the existing roadway. So that's, a way that we expanded this beyond just, OD to preset geography, getting the relative number of short trips, but it was very important to us to be able to, also estimate the relative number of users of these new connections. And then as far as how we looked at the data, we used the trip attributes data that I'm sure many of you have worked with in various ways that we referenced earlier. And so this used the StreetLight index for the relative trip number estimates, and then multiplied this by the percent of trips less than 5 miles. So if you can kind of see the table that's shown there on the right, the first column here is the StreetLight index for the relative trip estimates on each of these corridor segments evaluated. And then StreetLight does provide information on trip length. So here is percentages or proportions for trip lengths between 0 and 5 miles. And so by multiplying those two numbers, the highlighted value in the middle column here is the number that was used for the demand score for our prioritization. So those scores for the region are shown, the relative scores on the map on the right there. And so these values were used for prioritization, which increased prioritization in corridors with a high volume of short trips. So we were glad for that outcome. It definitely did improve the scores of some of the projects that you can see would have a high demand, a high number of users. So a couple limitations I'll note. When routes would differ between bicycles and pedestrians, of course, what we're using here is the all modes trip length. So there already and in the future would be some trips that would be shorter by bicycling or walking than by vehicle. And obviously there are other things that would impact the actual demand for a facility, that would impact the likelihood to walk or bike. In Charlottesville, hills are one of those main things. But even if all the infrastructure is there and kind of our long-term network that we're planning, there are a number of other things that would impact the actual demand for these facilities. This is, of course, a general solution that worked well for our planning process, but it's not a precise model or measure of future users. So, we weren't trying to say this exact number of people will use this new bridge. It was, relative numbers and relative evaluation. So finally, yeah, it did work quite well for this project, provided more appropriate demand estimates for project prioritization than using AADT or any other method that we had easily available. And I'll note, or some just final notes, the new bike ped tools. So since we just wrapped this up, we didn't have any of the StreetLight bike ped data available. We also didn't try to calibrate with any counts on actual existing paths or anything. So I was really looking far ahead to potential number of trips. But yeah, the new bike ped tools could be integrated into this sort of thing to determine where people are bicycling and walking already and where they aren't. So that's something that would obviously be helpful for implementing our plan we created. And the StreetLight bike ped tools, I could also see doing a more in-depth analysis of usage of different types of facilities. So, paths versus bike lanes, that sort of evaluation. And also something that already came up in a discussion I had today was the sort of evaluation of the benefits of new infrastructure. So how things change when new infrastructure is put in.